Question number 18 is, if A and B are square matrices of same order such that AB is equal to BA, then prove by induction that AB raised to power n is equal to B raised to power into A. Further prove that AB raised to power n is equal to A raised to n, B raised to n for all L belong to n. First of all, we will prove this. We shall prove by principle of mathematical induction. We prove this result, this statement in 3 steps by taking 3 steps. Step number 1. First of all, let Pn statement is AB raised to power n is equal to B raised to n for all n belong to set of natural numbers. Now see the step number 1. For n is equal to 1. Therefore, put n equal to 1 here. The statement becomes AB raised to power 1 is B raised to power A. See here, AB is equal to BA. It is given. Therefore, P1 is true. The statement is true for n equal to 1. Now we will assume in the second step, let us assume Pn is true for n is equal to k. K belong to natural numbers. Therefore, Pn statement becomes Pk is such that a b raised to power k is equal to b raised to power k into a. For all k belong to set of natural numbers. Step 3. We shall prove Pn for n is equal to k plus 1. Therefore, Pk plus 1 becomes a into b raised to power k plus 1, which is equal to, see, a into b raised to power k into b. Now by the step number 2, a b raised to power k is b raised to power k into a into b. By step 2, but we are given here ab b raised to power k into ba, because AB is equal to BA given. So we will use this result here. So now see, B raised to power K into B into A is equal to, this power is 1, therefore BK plus 1 into A. Now see, the PK plus 1 statement becomes a into b raised to power k plus 1 is equal to b raised to power k plus 1 into a for all k belong to set of natural number, implies pk plus 1 is a true. Therefore, by induction, by the principle of induction, Pn is true for n is equal for all n for all is true for all n belong to the set of natural numbers. Now in the part 2 of the question, see, now we will prove that ab raised to power n is equal to a raised to power n into b raised to. Let Pn statement is ab raised to the whole power n equal to a raised to power bn for all n belong to the set of natural number. We shall prove this by the principle of mathematical induction. Step 1. For n is equal to 1, P1 will be ab raised to the power 1 is equal to, that is, P1 becomes ab is equal to ab. ab is equal to ab, therefore P1 is true. ab is equal to ab, which is true. Now step 2. Let us assume Pn is true for n is equal to k. K is a natural number. Now pk statement is equal to a b raised to the whole power k is equal to a raised to power k b raised to power k for all k belong to set of natural number. This is assumed step. Now we shall prove Pn for n is equal to k plus 1. Now pk plus 1 statement becomes, see here, put ab raised to n is equal to k plus 1, which is equal to ab raised to power k into ab. Like this. By step 2, we use the step 2, a raised to power k into b raised to power k into ab by step 2. Now see, we know that ab is equal to ba. ab is equal to ba. It is given to us. Now we will use this. Now associate these two. B raised to power k plus 1 into a. B raised to the power k plus 1. Now see here, and in this result we have already proved a raised to power k into a into b raised to power k plus 1, because ab raised to power n is equal to b raised to power a, which we have proved already. So if we use this n is equal to k plus 1 is n, if we use this relation, then we get this. Now this is equal to a raised to power k plus 1 into b raised to power k plus 1. Now we have proved p k plus 1 statement, ab raised to power k plus 1 is equal to a raised to power k plus 1 b raised to power k plus 1. Therefore p k plus 1 is true. Hence 3 steps are true. By the 3 steps we can say that, hence by the principle of mathematical induction, Pn is true for all n belong to the set of natural numbers. So this statement is also proved by the principle of mathematical induction.